AP campers. Ooh, that's wrong too. We are going to talk about today percent composition. And like I mentioned in class, it's really not that big a deal. Please try not to make it a bigger situation than it is. A lot of times people see or hear that, oh, we're going to actually do some calculations, and they get nervous. So this is truly just what it says, a percent composition. How much do you have over your total times 100? Now, where are some little tricky places? Well, one of the tricky places is this, times 100. When you finish the ratio that you have here, this division, where you're taking the amount that you're interested in and you're putting it over the total amount, and there's different ways to get your interested amount and your total amount, which we'll talk about it. That's why there's 3 boxes below this, because there's 3 different approaches. Just remember to multiply by 100, because if you're in a multiple choice situation, they'll always give you the answer where it is not multiplied by 100, and you might look at your calculator. Well, you won't have a calculator, but you might look at what you scribbled down on your paper and say, oh yeah, that fraction's point whatever, and you circle that because you forgot to multiply by the 100. So please, please, please do not forget to do the times 100. So pretty straightforward is to use formulas and formula masses. So again, building, we learn how to write a formula from a name, and then we learn how to calculate a formula weight of the whole thing. So formula weight is the whole, right? So when we talk about the whole, we're talking about formula weight. Whether you want to call it molar mass, or you want to call it gram formula mass, or formula weight, that's going to be your whole. And really, weight is a misnomer. We're really measuring mass. But it's like a bad habit that you can't change. And so people say formula weight, but it's really formula mass. So here's an example, very straightforward, calcium chloride. Okay, so here's calcium chloride, and I want to find out the percent. And notice it says by mass, so it means that you're going to use grams, because you can do things like percent by volume. Another type of measurement we'll get into later. But we're going to do mass, so that means you're going to take the mass of the calcium and, chlorine, because we're working with chlorine, and you're going to put it over the total mass of the compound. So when you look at your formula, we have 2 chlorines, so when we go to find out the mass of chlorine, we have to multiply it by the 2 to get how much chlorine there is in that total formula. And then we also have the calcium. So off of your periodic table, you go and use your periodic table as a reference. Your chlorine weight is 35.45 to the 2 decimal place. There's 2 of those. And then you have 40.08 for your calcium. So this is your total again. So this is that whole thing on the bottom. That's your total. And it's part over the whole. Again, here's your part over the whole. Okay, times 100, because it's a percentage. Notice, here's a little rhyme. This is what my chemistry teacher used to do. Mr. Johnson was his name. He would say, just part over the whole by itself equals a mole. Part over the whole equals a mole. Part over the whole equals a mole. But if you multiply it by 100, you have now changed that into a percentage. Okay, so when you multiply by 100, it's a percentage. We're going to learn later on that you can change that into a parts per million by multiplying by a million, a parts by billion by multiplying by a billion, a parts per trillion by multiplying by a trillion, which is interesting because I just read an article about bottled water quality, and that they measure for certain plastics and contaminants in making plastics, as well as heavy metal contaminants in these bottled waters. It's a whole report on Consumer Reports did it. And they actually measure, and I'm trying to remember the name of the chemical that's linked to birth defects and cancer, in parts per trillion. It's a real life example there. So we are still focusing on percentage though, so our multiplication factor is 100. That's straightforward from the formula. We have another formula that we are going to look at, and actually these two, And I can't use the pen, it won't work on Loom. So, let me just go back out this way. And I hate doing this too because it's like, it shrinks and then it gets bigger. These two over here, which get cut off for whatever, these are formula calculations. The one on the bottom is lab data calculation. Okay? So in the formula that is in the second box, we have a hydrated one. So this comes mass percent of water in a hydrated crystal. Okay, remember there's that dot H2O there. It's hard to see over the writing, but you have it in your notes. So there's so many. Remember the one that we talked about on the previous page was this one? That's a hydrated crystal, right? This is the water part. This is the whole part. Let me change my color here. A good anhydrous color. Yeah, well, this part is anhydrous part. Okay, so this is the anhydrous. I'm going to change the water part to a blue underline. This is the water part. And then this is the whole. Could they ask you for anhydrous percentage? Yes. So be aware of that they can ask you for either percentage on there. So this literally, again, is by formula. If you know the formula, you use the formula. Now, here's the thing. They will give you mass and mass percentage, mass of the whole, mass percentage, and they'll say, find the formula. Ooh, we're going to do that next, not on this slide, but the next page, where you link together percentage and this thing called empirical formula calculation. Again, it's ratios, just ratios, guys. Nothing big, no big fancy thing, just ratios. So let's split this apart. Again, if we look at the sodium, I'm trying to remember what 12 is. Oh, dodeca, no, that's 20. Well, 12 hydrated waters. Isn't this awful? I have a brain blank and I can't remember the prefix for 12. And here's my little dot in there. So the whole goes all the way through the formula. And then we have two parts. Again, anhydrous and anhydrous, or water part. So the anhydrous crystal is the part without the water. That's the anhydrous. I'm going to abbreviate it. And then the part over here is your water. And when they want the water percentage, that's the part. And then the whole thing is the bottom of the whole. Now, how I do it, guys, is I split it. I actually split it into anhydrous and just the water. So on this part of the notes is the anhydrous. 3 sodiums, 1 phosphorus, 4 oxygens from this formula. Find the mass. On the other side, I have 12 waters. Now, there's 2 ways to do this. You can do it the way I did here, where it's 12 times 2, so I have 24 hydrogens, 12 times 1 oxygen, 12 oxygens, and I add it up. But the other way you can do it is you can say that it's 12 times the weight of a water, and the weight of a water is 18.02, so it's 12 times the 18.02. Either way, okay, as long as you get your final mass of your water. Now, to do the total and the whole, you add them together. And now you could get the percentage of either part. It's easy, because if you have your total for your anhydrous, you would put that over the total mass of the compound. But we're focusing on the water, so we take the water and put it over the total, and we multiply by 100. Again, straightforward. Straightforward, just part over the whole times 100 equals percentage. Right? So, the last little box on here has to do with lab data, right? So you're in the lab, and we normally do this lab, but because the fingerprinting is out and it's a mess on the lab benches, we will wait till our forensics friends finish their fingerprinting and lifting fingerprints, and I'll clean all the powder off so it doesn't go all over you, and we will do these upcoming labs for our calculation part. And so one is to drive the water out of a hydrated crystal. We're going to use the pretty blue crystal. We're going to turn it kind of an ugly white-gray color, and then we're going to rehydrate it. Okay? So how do we do this? Well, a lot of times you're given data, lab data, And in that lab data, I mean, right here, it just gives you the mass of the hydrate and the mass of the anhydrous. Hydrate means the water is in there. Anhydrous means it does not have the water. So to get the mass of the water, you subtract the two, so that's this right here. Oops. Sorry, I thought I was in my right on thing. So to get the mass of the water, you do the subtraction. That gives you the mass of the water. But this is the total. So if you have the total already, we don't have to go much further. We just take this part and put it on the top, and we take the total and put it on the bottom, and we divide. And actually there's an error here because this is the proper way to record your subtraction, which is only 2 sig figs. So this really should be 6.2%. I don't know why I wrote 3 sig figs. Now guys, you have to understand it gets a little more complicated when they give you lab data. This is a straightforward one. They actually could give you a question like this. But usually what they do is they give you a mass of an empty crucible or evaporating dish. I'll use crucible. And they record it. And I'm just going to say usually crucible runs around 17 grams. Okay. Then they'll do mass of crucible and hydrate. And you would then say, okay, that's everything, the crucible and the crystal together. So I'm going to say 17.80 grams. And then mass of anhydrous in crucible, because you heat it in a crucible. We actually use an evaporating dish because the water gets driven off better, and the evaporating dish cools faster than the crucible. So that's what you would be given for data. So to find the mass of the water, you just subtract the crucible and the hydrate minus the crucible and the anhydrous, so that'll give you 0.2 grams. And then mass of the hydrate is the top two subtracted. That's going to be equal to 0.8 grams. And then you can do your percentage. Okay, so you can do the 0.2 over the 0.8, which is what, 1/4, so that would be 25%. So understand 2 ways to get your, well, 3 ways. You can be asked to do a hydrate, which people say is a little different than a straightforward formula. You can be asked to do a straightforward formula, or you can ask to do something from lab data. Okay, so this is from lab data. So when you're doing stuff from lab data, they will ask you to think about like what causes error. What would happen if you heated something too much or too little? So they'll ask you to think about that. So I'm going to go over to page, 8 in your workbook, just to do a couple of examples. I'll do one. So I'll pull this up and we'll look at it. So on page 8, which we'll end up doing in class, but I'm just going to give you this example so you can see it calculated. It says determine the percent composition of each of the compounds below, and they want each element. Right? So I have potassium, magnesium, and oxygen. So I'm going to do the total. So my total would be, I've got 1 K, 1 manganese, and 4 oxygen. That's 64. You learn that 4 times 16. So let's see, manganese is 54.94. And then potassium is 39.10. So we add these up. And we get our total. Come on, you. I get 158.04. Now to find the percentage of potassium, I'm going to take 39.10, I have to divide it by the total, and then I'm going to multiply by 100. Same thing, manganese, 54.94 divided by the total, multiply by 100. 64 divide by the total, multiply by 100. I'll just do the first one because I think, oops, you'll get the idea after I do one. So I have 24.74%, and then you fill it through. Okay? On the next page, it is doing percentage of water. So water, this is the part that I'm looking for, and then this is the whole thing. So it's a very similar type of thing. You would do the water. I have 5 H's. 5 times 2 equals 10 H's. 5 oxygens. Right? So that would be 10 times 1.01. 5 times 16. And you add it together. And I got 90.1 grams. And over here, you've got 1 copper, 1 sulfur, and 4 oxygens, and 4 oxygens, 64. 1 sulfur is 32.06, and a copper, oh, I can't remember copper, 63.55. Again, you're going to total this up. You're going to add these two together. So that's why I do this thing where I add them together. So it's 159.61. We're going to add 90.1 to that, so the total is 249.71. And so if we go to do the percentage, it's 90.10 over 249.71 times 100. So that's going to be 36.08%. Okay. Alrighty. I think you get the idea. And that is percentage with some examples.